Who used the chat? These two chats.
Morning room here, sir. Morning session. Let's do late and like that.
Hello, sir.
Yeah.
Am I audible?
Yes, audible.
Invisible?
Audible. Yeah, you can start. Yeah.
Thank you, sir. So, good afternoon, everybody. I'm Sharanya from Vidyajyoti Institute of Technology, studying third BTech in the stream of ECE. We are of Team 5, Raj Nayak, Sharanya, Kanchan, Vinay, and Nabil. Our supervisor is Dr. K. Vasant Kishore Garu, and our college name is Vidyajyoti Institute of Technology. And project name is DPK. DPK stands for Dhanyam Panche Kiosk. Dhanyam and Panche are Telugu words. Dhanyam basically means food grains, pulses, cereals, etc. Panche means something which we give. Kiosk means a separation chamber. It is a basically Persian word. In order to separate ration, here we are using chambers, so we named it as Dhanyam Panche Kiosk. So basically, our mission is about automatic ration distribution system. So very recently, we have visited a ration shop nearby home, and we found many difficulties faced by normal people all over the ration shops. Let's say the ration dealer actually weigh manually ration and give the ration manually, and the ration dealer manually entry all the details manually, and also people stand for longer hours in order to collect their ration. Don't you feel uncomfortable when you stand in long hours in order to collect your ration? I'm sure it does. Even I feel the same too. And also we need additional people to be employed for monitoring and all. So due to this, there is a possibility of scam involvements and some proxy issues. And these are the pictures that we have collected very recently when we went to ration shops. And these are the pictures when we have collected in COVID times. It is okay in normal situations to stand for longer hours without any social distance, but it's very horrible and very hard to maintain some social distance in the ration shops or in the ration queues. We found a similar problem in the supermarkets too. So basically in supermarkets, we collect our ration or the groceries which are in different chambers, and we never know the approximate weight of any ration or any grocery. So for that we need extra weighing system and extra barcodes and all to check our weight or to check our groceries. So these are the pictures that we have collected when we went to supermarket. And keeping all these points in view, we have come with a solution that is automatic ration distribution system. So this is basic simple prototype that we have made in the beginning days. We have made this as a prototype. So basically, the advantages with our proposed prototype or proposed system are there is no ration forgery happening in this proposed system, and also it is cost efficient, and we use load cell to in order to weight this ration. So this load cell will give accurate weight of the ration. Also, here we are using image processing, I mean the face recognition instead of thumb and iris, because though we have thumbprint system already in the ration distribution system, it is said that most of the laborers lose their thumbprint after doing so much labor work in the hard soils. So if that is the case, there is a possibility of people not getting ration for that 1 month. So so we thought we cannot include this thumbprint. So we thought of planning to do using iris scanning, but it is said that iris scanning is so costlier. So we have ended up this by doing this facial recognition. And due to this facial recognition, whenever a person stands in front of the camera or in front of the system, it will automatically, based on our database that we give, it automatically identify the person who is standing in front of the camera, and identify that he's a right person for ration taking, and then automatically the ration turns on, the servo motor turns on, and the ration comes and falls in the container, and automatically when we reach a certain weight of that specific ration, it servo motor automatically turns off. And due to this proposed system, we can avoid corruption, we can eliminate proxy issues, and also most of the people who stays in villages sometimes move to some other places for any other causes, or due to any emergencies. That time, if a person moves to specific place to specific another place in beginning days of month, he might not get ration. Instead of that, he can go to the ration shop which is nearby the place he's residing, and he can take ration anytime when he want. And so basically, that's why we call this as ATR, which means anytime ration, as in ATM, like anytime money. So whenever a person is comfortable in taking ration, he can take that time after 1 month. So coming to reachability, Nabil will take it.
Thank you, Sharanya. I am Nabil. So, how are we going to implement this TPK into the market? So, basically, we have divided it into small scale and the other one is large scale. In the small scale, the overall cost is around 11,000 rupees, and in large scale, it is around 26,000 rupees. The reason behind the higher cost in large scale is because of a powerful microcontroller known as Raspberry Pi. We can implement our Python code in Raspberry Pi itself, and also we are installing a buzzer which switches on when the desired weight is obtained. And also we are introducing a camera. Because of this, the cost is high. And if we are installing a camera and a Raspberry Pi, so because of this, the desktop can be replaced. But still, we need a desktop or a mobile so that we can track the data who is collecting the ration. And we will be providing free maintenance cost for a year. Our key partners in the case of small scale are local kirana shops, supermarkets, etc. And in the case of large scale, it is the government agencies and the public distributors.
So basically, first we want to include our mission in first of 50 supermarkets, which is in small scale, that is in smart city, smart superstores and in DMarts, etc. And when it comes to large scale, we want to implement our mission in first districts, and then next to states, and next to overall India. And ours was a basic prototype in the beginning, and then this is how it looks. And later, using some 3D printing, 3D modeling, with the help of mechanical engineering people, we have designed our machine so like this. And the final output of the proposed system looks like this. And this is a working model of the proposed system, and this is how it works. So basically, when a person stands in front of the laptop camera, now we are using laptop camera. So when right person, we have already included person database into this laptop. So after recognizing this face, it shows that the person is some name, and once the image is authenticated, servo motor automatically turns and the ration automatically falls. And here we have limited the ration weight up to 500 grams, I guess. So yeah, 500 grams. After 500 grams pour into the container, the servo motor automatically turns off, and we can collect the ration. And this is how our proposed system looks, and thank you. To reach us, you can contact to this phone number or to this mail ID. Any more queries?
Thank you. Any questions, sir? Any questions from the participants? So if there are no questions, we'll move on to next team. Yeah, team 15, are you ready?
Yes, sir.
Yes, sir.
Yeah, please share the screen. Thank you, team 17.
Thank you, sir.
Team 15, digital twin smart farming for pesticide spraying and water management
Yes, sir.
from Agabada Institute of Technology.
Yes, sir.
Yeah.
Good afternoon to you all, sir. Myself, Zadmir from AAA third year students of the BIT College. Sir, thank you for Vardhaman College of Engineering for giving me this opportunity to explain our prototype. Our prototype is about digital twin, smart farming for spraying pesticides and water management. And my team member is Konraj, Zahid and Prasad. Our motto is to do, sir, innovation in agriculture sector. And the first problem in the agriculture sector is, as we know that pesticides is used in crops to kill pests, including insects, rodents, and unwanted plants such as weeds. According to World Health Organizations, about 1 lakh human beings are affected by acute poisoning by contact with pesticides. It can cause skin disease ulcerations. And the second problem, as we know about 85% water is used in India for irrigation only. Only 1.5% in industry and 6.6% in domestic. This irrigation is used in large scale. So this we can save the water. These are the problem we faces in agriculture sector. So in this project, the first solution for the first problem is we are going to do proper using of pesticides and can stop from having acute poisoning by contact with pesticides by a moving robot, which we made using digital technology. And the solution for the second problem is we are going to manage water all agricultural field and to detect any water leakage between the valves in the system. It means that we can detect any water leakage in the system, we can detect by which things this digital twin technology. And what is this digital twin technology is, it is nothing but it is a virtual representations that serves as the real-time digital counterpart of a physical object. It consists of three distinct parts: the physical product, the digital product, and the connection between the two products. The connection between the physical product and the digital product is data that flows from the physical product to the digital product, and the information that is available from the digital product to the physical environment. It can also be used for monitoring and diagnostics and prognostics to optimize assist performance and utilization. In this field, sensor data can be combined with historical data, human expertise, and fleet and simulation. One of the characteristics of digital twin technology is its connectivity. The recent development of the Internet of Things brings towards numerous new technology. Now, about these things, the components of this smart farming, it means spraying pesticides and water management. I'm inviting my friend Punraj who will explain about these things. Thank you.
Hi, this is Konraj. I'm going to explain the block diagram of the prototypes we have made. The first prototype is pesticide spraying. In this block diagram, here we can control a robot with the mobile app. We developed here the HC05 Bluetooth model. You can see here in the block diagram. Using the Bluetooth model, we can connect the robot with the mobile app. Here we using at Mega 328P Adreno model. It controls the whole system. There is also a relay model you can see. It is used for switching on and off the DC motors of the robot. By looking the robot, we can see a pumping motor that will take pesticides from the tank and spray it through the pipe to the fields on the agricultural field. While we moving the robot, it will spray the pesticides. It can also move in bi-directional, and we can control the speed of the robot also. Okay, next we see the prototype. We have made another one, water management. In this water management, we can see we use here also a mobile phone to control the solenoid valves that are set in crops. Here the node MCU will act as a controller here, and it also contains a relay model to open or close the solenoid valves in the agricultural field. And either we have a flow sensor next to the solenoid valves, it will measure the water flow and detect any leakages in the pipes. And the water will flow from the tank and through the C2V pumping motor to the solenoid valves to the agricultural field. It is our hardware setup we developed for spraying and the water management. Okay, let's see about brief about components we use. This is the Arduino at Mega 3280 model. This is the Arduino at Mega 3280 model. It is used in the pesticide spraying prototype. It will act as a controller and it will function all the process with the help of the microcontroller. System we use a C++ program to function the process. We should write the program in the computer system, and upload in the Arduino model by using a USB cable, and we can power it with a AC to DC adapter, or you can use a battery. Next, the HC05 Bluetooth model. It is connected to the mobile phone through Bluetooth. It has a 2.4 GHz frequency band, and the transfer rate of the data can vary up to 1 Mbps. And the model is operated within 4 to 6 volts of power supply. The motor model is set within Arduino model. Inside the Arduino model, it will control the motor's action. And we can now see the components of the water management, second prototype. It contains a node MCU. In the node MCU, it is a controller here. It controls all activities in water management. It is mostly used in IoT-based applications, and it is runs on ESP8266 Wi-Fi, the ESP12 model. Next component is solenoid valve. It is the main component in this prototype. It is used to flow the water from the tank to agricultural fields. The top, next and it can also detect any leakage in there, or any pipe burst within the joints, or any change in liquids are mixed with it. We can see. Next, this is a small product we have developed, and we get a pattern for this. It is also same type of that solenoid valve. This valve will help in some apartments to detect any leakages, or we can set a specific amount of water. We can see through this. Okay, our teammate Prasad will conclude this project.
Any questions, sir?
Hello, sir. Audible?
Your voice is breaking.
Audible, sir.
Your voice is breaking, though. So go to your block diagram slide. So okay, any questions from the participants? Sir, any questions, sir? Okay.
Yeah, one more, Professor. One
Yes, sir.
question.
Yes, sir. Yes, sir. Yes, sir.
Yeah, very good afternoon. The batch, who is his name?
Ponraj.
Ponraj, right? Yeah, Ponraj. This is the device which can be moving on the ground, right?
Yes, sir. Sir, we have a video for that, sir. How the prototype.
Okay,
Shall
so
I put?
it can be moving on the dry lands or wetlands.
So no, sir. We can set up for a wheel. We
For
can
the
set up.
wall only, not robo, right? Okay. You are fixing the setup for the wall, right?
Sir, what, sir?
Or spare. You are fixing all the IoT based setup for the wall or motor.
Sir, for the solenoid valve.
Monitoring robo, you are saying monitoring robo, IoT pesticide spraying, right?
Yes, sir.
Moving robot.
Yes, sir. We can control with the mobile phone, sir.
Mobile. Okay, okay. Okay, right.
Thank you for the presentation. Let us go with the next team. Team 16, Ravi Teja. Vamsi Krishna and Pravalika.
Hello, sir. Am I audible, sir?
Yeah, it's audible, audible. Team 15, yeah, team 16, please share the screen.
Let's share our screen.
A 4-way power bank.
Yes, sir.
From team 16 from CMR College of Engineering and Technology, Ravi Teja, Vamshi Krishna and Pravalika.
Sir. Hello, sir.
Yes, your screen is black. Please check. Yeah, now it's visible. Please share your presentation.
Sir, is it visible?
Yeah, your Teams, Microsoft Teams app is visible. Please minimize it and share your presentation. Okay. Minimize the browser and open your PowerPoint presentation file.
Sir, is it visible now?
Yeah, it's visible, but the presentation file is not visible. Your browser is only visible. So open your PowerPoint file, minimize your browser. Please minimize your browser and open your PPT file. Screen is shared only.
Just 1 minute, sir.
Yeah, okay.
Sir, is there any other way to share our PPT, sir? We are next to share our PPT, sir. Hello, sir.
Please share your PPT in the WhatsApp group.
Yes, sir. One
Yeah, I
minute.
will try to share. So team 18, are you ready? Single axis solar tracking system. Team 18, Sandeep, Praveen Nayak, Tarun Sai, and B. Akila from Bharat Institute of Engineering and Technology. Okay, team 19.
Sir, we are ready, sir. Project batch number 18, we are ready, sir.
Yeah, please share the screen and start the presentation. Please share your PPT.
Yes, sir. We are on it.
Your screen is visible. Please start the presentation. Team 18. Sandeep, Praveen Nayak, Tarun Sai, and Akila. Please unmute your mic.
Hello, sir. Hello, sir.
Yeah.
Good afternoon, sir. First of all, thank you, Vardhaman College of Engineering, for having us here. We are from Bharat Institute of Engineering and Technology. We are here to expose our major project titled with single axis solar tracking system. Sir, our group consists of 4 people: P. Sandeep, Praveen Nayak, Tarun Sai, and Akila. We have done this project on the guidelines of Mr. K. Srinivas Rao, sir. So yeah, we are here to discuss the major context of our project, which consists of objective, introduction, literature review, block diagram, hardware setup photograph, results and discussion, and conclusion, sir. Coming to the objective of our project, our main objective is to produce a maximum output from the solar rays by tracking the solar rays from the sun. We have used a single axis solar tracking system which tracks the solar rays in one direction, in the forward and reverse direction. Coming to the introduction of our project, the solar tracker will track the radiation perpendicular to the axis. By this we can conclude that we will receive the maximum solar intensity from the sun, which includes the maximum efficiency compared to the standalone system. The tracker will move according to the sun's direction by the times we have fixed to it. Coming to the literature part, we have taken the reference from these. The next part will be continued by our friend.
Hi sir, myself Akila. I'm here to tell about the block diagram of the single axis solar tracking system. The main unit of the solar tracking system is PLC unit. We are supplying the to 24 volts from the battery. In the PLC unit, there are three components, anemometer, temperature sensor, inclinometer. The main aim of the anemometer is to measure the wind speed. Temperature sensors are used to measure the temperature of the solar panels, so is minimum or maximum of the solar modules. Inclinometer is used to set up the inclination of the angle. From these three things, we are taking the linear actuator and connected to the solar panel. We getting the output of the electricity. It is connected to the directly load. That's it. Next, continued by my friend Sandeep.
Hello, sirs. Good afternoon. Myself, Sandeep. So I'm here to explain how our tracker will work. So initially, we are giving PLC. We are giving some set of instructions to the PLC unit, and we'll giving supply to PLC unit from the batteries which we have taken. So to the batteries, we have used a feedback system, like nothing but whatever the amount of electricity we are generating, that will given to the battery, so we can utilize the power which is coming from the solar panel, and as well as we are using that generated electricity to the load also. So in PLC unit, what will happen means we are using HMI device, nothing but human and machine interface device. So in human HMI device, it consists of PLC unit. In PLC unit, we are written the program in such a way that the uh, the tracker will automatically senses the sun's angle, and as well as based upon time, the tracker sense the position of the sun, and it itself adjusts to the position where it has to be based upon time and based upon sun angle. So from that, the PLC unit will give command to the linear actuator, and from the for every 2 minutes, the linear actuator will move 2 degrees forward or 2 degrees backward. So from that, we can track the panel, and that panel will be in its position where it has to be based upon time. So these are the hardware setup. So first, initially, this is the setup where at the tracker is at 10:15 a.m. And if we look into the second picture, the tracker is at noon position, nothing but at 12:21 p.m. the tracker position is this, and at evening nothing but at 3:08 p.m. the tracker is at this position. So initially, the tracker facing towards the east side. So if we look into the reference of this red color, if we take the red color box as reference, initially the tracker position facing towards the east side. So at noon position, the tracker is at flat, and at evening time, the tracker is at facing south direction. So if we look into the reference box, initially the box is at upward direction. Now the tracker is at downward direction. So these are the hardware components which we have been used. So the first picture indicates HMI device, nothing but consists of PLC unit. So in this, we have used the HMI device consists of 2 modes. One is manual mode and another one is auto mode. So if the four buttons indicates red color, that is in auto mode. If the first button indicates green color, the tracker is in manual mode of operation. So the next picture is the connections of relays and HMI device. The third picture indicates PL linear actuator motor. Fourth one is anemometer, which measures the wind speed. The first picture indicates inclinometer. So purpose of inclinometer is to track the angle, inclination angle of a particular device, which user required to measure the angle of a certain device. The specifications of this the specifications of this inclinometer is it will take it will rotate up to 0 to it will track the angle of 0 to 360 degrees. So from the inclinometer we are giving feedback loop to the HMI device, so that can track the sun's panel solar panel, and gives to the HMI device. So the HMI unit will display the tracker angle. So the next thing is pyranometer. So pyranometer, we all know that we'll use pyranometer to measure the irradiance of a solar panel. And in this setup, we have written program in HMI device up to from in HMI device we have written angle from plus 23 degrees to minus 23 degrees. So at initial stage, the tracker is at plus 23 degrees. At noon, it will be in 0 degrees centigrade, 0 degrees, and at evening side, the tracker position will be minus 23 degrees. So this is the thermal sensor. So thermal sensor, we have stick to it to the solar panel. So based so the thermal sensor will sense the solar panel temperature, and it will give to the HMI device. So we can measure the temperature of a solar panel. And this is the battery connections and charge controller. So in this we are using charge controller. Why means we have to control the charge. So we have to protect our system. So these are the results. So the graph indicates voltage versus time. So these are the graph data shows 1.5 hour data. So this is the voltage graph, and this is the power graph. This is the temperature graph, and this is the result of irradiance. This is the result of current. So these are the results of our project. And coming to the conclusion, so in this we have to conclude that we have been concluded that the tracker has more efficiency when compared to standalone system, and the maximum amount of power can achieved by using of solar tracker system. Also, we have implemented protection for this system based of by using of anemometer. So here's the demo video of our project. Based upon that, now the time is 12:50 now. So I'm installing this tracker from auto mode to manual mode. So now I'm operating this tracker in forward direction. First direction manually. Operations nothing but forward direction mode and reverse direction mode. Now I'll switch this manual mode to auto mode, so the tracker will itself adjust to its position where it has to be now based upon sun angle and based upon time. So this is the demo video of our project. In this way, we can control the tracker manual or auto mode. So the disadvantage of manual mode is every time we have to manually operate whether it has to move forward direction or whether it has to move reverse direction. But if we kept in auto mode, automatically it will adjust itself to its position where it has to be based upon time and based upon sun's angle. So thank you for giving us this opportunity. Any queries? Any queries? Ask. Please ask.
Thank you for the presentation. Sir, any questions, sir? So you will be tracking the position of sun by using which sensor?
Sir, we are sensing the tracker position based upon time, sir.
Time only. Okay.
But we can also sense based upon latitude and longitude, sir. We have to give latitude and longitude angles to the PLC unit, so it will track based upon that longitude and latitude. But in this project, we have been given based upon time, sir. It will sense based upon time.
Okay, but one question I am having, suppose if there is any shaded portion is there in your panel, any particular part is shaded. Okay. So at that time, it may not be giving a maximum power. So at the time, what we will do? Maybe in some other position, you may have maximum power, since in that position, your panel is somewhat partially shaded.
Sir, during shaded portion also PLC unit will have time, sir. It will timer PLC unit having timer, sir. So we have given timer to PLC unit also.
Okay, it will wait for some time. After that, what it will do?
Sir, it will adjust to the angle where it has a maximum intensity, sir.
Okay.
For that, we are implementing that pyranometer now, sir. So it will measure the radiance of sun. I mean sun's rays.
Okay. It's okay. Thank you. So any questions, sir? Any more questions? It's okay. Thank you for the presentation. Let us go
Thank
to
you, sir.
back.
Thank you for giving us the opportunity.
Thank you
to
so much,
present.
Vardhaman College, for having us here.
Yeah, thank you. So let's go back to team number 16. Are you ready?
Ready with the presentation.
Yeah, please share the screen.
Can you able to see, sir?
Yeah. Okay. Yeah, it's visible. Start your presentation. Yeah.
Good afternoon, everyone. I'm Pravalika from CMR College of Engineering and Technology. First of all, thank you for providing an opportunity to present our idea in IEEE Project Expo of 2K22. We, the team of 3 members, our project idea is about a 4-way power bank. Coming to the problem statement, we know that there is a lack of availability of electricity for electronic gadgets to communicate with the people when the person staying or visiting near far away places like tourist places or remote areas and so on. And where the supply is not available, there are people are suffering to charge the gadgets. For this, we come up with an idea called four-way power bank. Um, Generally, we know that power banks are not just a simple battery. They use sophisticated electronics circuitry of to manage the being charged and then charging other devices. And for further about our project four-way power bank, our teammate will explain.
Yes, sir. Detailed problem description I will tell, sir. So nowadays, during traveling far away places, our electronic devices plays a major role, now, sir. Most importantly, our mobiles, we have to communicate with others, requires more charging, sir. In remote places and while traveling tourist places and in like where the less people uh, the people were not able to charge the electronic gadgets to communicate with others. Uh, our 4A power bank is very helpful, sir, and it is necessary to charge our communication electronic gadgets in remote places to communicate with others in any condition, that is high times. Uh, Sir, coming to our 4A power bank, sir, we suggested a solution, sir. That's our project 4A power bank. To overcome this problem, sir, our project come up with four non-renewable energy sources, sir. That is one solar energy, then another one wind energy, and another one hand-driven mechanical energy, and last one, sir, that is also already existed one, normal charging rectifier circuit, sir. And by interconnecting these four ways, we constructed a four-way power bank, sir. Existing solutions are normal power bank and also solar power bank, sir. The difference between our 4A power bank and the normal power banks is normal power banks are dependent on electrical power supply, sir. But our 4A power bank is independent of normal electrical input. And solar power banks are dependent on electrical input and sunlight, sir. Uh, remaining uh, remaining all power banks are different from 4A power banks, sir. They will not helpful in where the supply is not available and where the sun is not available. They are not use. We can't use in the situations normal power banks, sir. We can generate in any condition by using our 4-way power banks, sir. Sir, when we went to our working, sir, one is solar energy. Sir, when the power bank is placed in sunlight, falling places, the solar panel of our power bank absorbs the light energy, sir. The light energy converted into electrical energy by using an array of PV cells which are inbuilt in solar panel, and the light energy which is converted light energy into which converts light energy into electrical energy, and electrical energy stored in our connected batteries, sir, through an rectifier circuit. To get constant output irrespective of input of solar panel, we are using the rectifier circuit, sir. The rectifier circuit gives us 5 volts constant DC output, sir. Why? Because we are using rectifier circuit is so the directly generated solar energy consists of pulsating DC, sir. That is not pure DC. For the cause of for the sake of getting DC pure DC, we are using rectifier circuit, sir. The rectifier circuit is connected at last to the battery terminals, sir. Battery terminals, and the battery terminals are taken out and connected to the another circuit, which is heart of our 4A power bank, sir. That is booster circuit, sir. Booster circuit, we all know, sir, generally the booster circuit principle is irrespective of any input current, that gives the 5 volts 2 amps current, sir. That is up to mobile phone, sir. We we constructed like that, sir, our 4-way power bank. To up to mobile phones only, we are constructed of 4-way power bank to get 5 volts 2 amps constant output. That is sufficient to charge our mobile applications, sir. And next, wind energy, sir. The next, another way, sir, by using wind energy, sir. Sir, generally, when the wind energy hits the turbine blade, it experiences a kinetic energy, sir. The kinetic energy, and the blade is connected to the shaft of the DC generator, sir. We are using here DC 5 volts to 12 volts generator, sir. That is connected to our fan blades, sir. Whenever wind hits the fan blades, that is connected to the shaft. The shaft generates a mechanical energy. The mechanical energy converted to the electrical energy by using DC generator, sir. In this way, we are generating uh, uh, electrical energy by using wind energy, sir. So next one is hand-driven DC generator, sir. This is also similar to previous one, but slight change, sir. Here we are using by using our hand motion, we can obtain kinetic energy, no, sir. The hand motion of the kinetic energy is converted into uh, mechanical energy, sir. The mechanical energy again converted into the electrical energy. And next, the electrical energy output is connected to the rectifier circuit, and the process is same, sir. Previously said thing, sir. The output of the DC generator connected to the rectifier output. The rectifier output is connected to the battery. And the battery output is connected to the booster circuit. The booster circuit having the two ports to receive the electrical energy. And next one, sir. Our prototype, sir. This is our prototype. So here you are seeing the prototype. This is a fan blade, sir. And this is a solar panel. And another one is here. Solar panel, sir. And another one here you are seeing, sir, left side of the poster. This is a hand wheel, sir. By using this hand wheel, we can rotate up to 0 to 10 RPM. That is sufficient to generate 5 volts DC output, sir. And next one, the next concept is explained by our friend, sir, Amshi Krishna.
Good afternoon, sir. Good afternoon, ma'am. I am Amshi Krishna. As the four-way power bank implies that it consists of 4 ways of generating the power. So the 4 ways are explained as explained by our friend. It consists of the solar, wind, hand-driven DC generator, and normal AC supply. So most of these are from the non-conventional energy sources, and we are using the non-conventional energy sources to produce the electricity, and we are using most of them are non-conventional energy sources, sir. Sir, by using the power bank for travelers, it can't be used, sir, because once the power bank got dried, so it can't be used further. Again, we have to recharge it. But in this four-way power bank, we have created a system through which the power is generated in it, and we can use the power itself from it. So we have designed in such a way that it can be used in remote areas where the power is not available also, and it can be used to charging the mobiles, charging the anything like mobile phones, etc., laptops, and electronic gadgets, which are from voltage ranging from 10 volts to 20 volts, 20 volts ranging. So in this way, by using the power banks, we are not able to use it. So we make this four-way power bank. So with the availability of solar, wind, hand-driven energy, hand-driven DC source, we can able to produce the electricity. So it will be used for the people in the critical times where the power is not available. We made it very portable so that it can be carried anywhere. And we are using the non-conventional energy sources so that for this so it encourages the people to use the non-conventional energy sources, and it requires it is less size because the batteries we have installed is of less capacity, because it generate the power, it generate electricity itself and discharge instantaneously, so that it does not require large capacity rating of the batteries. So uh, it is very eco-friendly because we are using all non-conventional energy sources. So in the in any conditions we are able to getting if there is availability of chance of getting at least solar or a hand driven DC generator is nothing but by using our hands, by rotating the motor at 5 to 10 rpm, we can produce the electricity. So it is so that we can get the electricity for charging our batteries, etc. We solar is available all the day, so that the user can be used to charge their mobile at any times, at any critical situation in the forest areas, in the tribal area, in the remote areas where the power is not available, so that it will be very useful, and it can be used for charging the lamps also. So we have come up with this idea on the above problems. It is very portable, and it costs up to 2,500 to 3,000, sir. So thank you for giving us this wonderful opportunity for presenting, and sorry for the inconvenience that we have experienced. So thank you, sir.
Yeah, thank you. It's no problem. So, any questions, sir? Any questions from the participants?
Sir, any queries, sir?
Yeah, wait, we'll see. From the participant side, any queries or questions? Yeah, thank you. No questions from anyone. So, okay, we'll go to the next team, team number 19.
Okay, sir. Thank you, sir.
Thank you. Smart automation from Sri Hindu College of Engineering and Technology. Shivakumar, Naveen, Varshit, Kishore, and Yashwant. Team 19. Team 19, are you there? Smart automation by Sri Hindu College of Engineering and Technology. Shivakumar, Naveen, Varshit, Kishore, and Yashwant.
Good afternoon, sir.
Yeah, good afternoon. Please share your screen and start the presentation.
Okay, sir. Can you give me a second? Good afternoon, sir.
Yeah, good afternoon.
Are you visible to see my?
Yes, it's visible. You can start.
Yes, sir. Good afternoon, sir. Myself, G. Shivakumar. I'm from Sri Hindu College of Engineering and Technology, and our project is about the home automation using a node MCU. Our team members are P. Kishore, Varshit, Yashwant, and Navin. Our main objective is to design and construct a home automation system that will remotely switch on and off any home hold appliances connecting to it by using the Wi-Fi module called Node MCU. And the problem is about now in some homes there are home automations and like Alexa's types, but we cannot operate the home appliances when we go outside of our home. So by this project, I'm efficiently implementation for the IoT used for monitoring and controlling the home appliances via World Wide Webs, and the system uses portable devices as a interfaces, and they will communicate with the home automation networks through the internet gateways means and it can slow power consumption and communication protocols like Wi-Fi and Zigbee, etc. And our main aim is about to controlling home appliances uh, with Wi-Fi uh, by accessing with our mobile phones, and we can easily switch on and off the uh, home appliances when we are out of our house. And this node MCU is an open source for the IoT platforms, and this user will mainly directly with the system through the web interface over the appliances like lights, fans, etc. And the server will be interfaced with relay hardware circuits that control the appliances running at homes. The servers communicate with the corresponding relays, and I'm 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 giving to my team member Kishore for the further project details.
Hello sir, myself B. Kishore. I'm here to explain about components. These are the components we are used in our experiments. Those are 4 SPDT relay channel and node MCU ESP8266 and relay driver. So what is relay? It is a power relay model. It is an electrical switch which is operated by an electromagnet. This electromagnet can be activated by microcontroller. Due to this, it can open or close the channels of relay. And node MCU is an open source IoT platform which runs on ESP8266. Its main function is used to operate and let connect objects and transfer data. And relay driver is used to operate and operate to make a relay channel function properly. And this is the power supply to give all of this. And in order to connect relay channel and node MCU, we use jumpers female to female. And the and working principle will explain by our team member Navin.
Good afternoon, sir. I am Navin. I'm here explaining about working principle of our project. We have taken 4 relay modules with we are taking 4 relay modules with 4 bulbs, which we can operate only 4 bulbs through 4 relays. If we increase our relays, we can operate more appliances. Uh, Relays are acts as a switches, which will control through our mobile, which is connected by our ASP module node MCU. It acts as a Wi-Fi, which we will connect through our mobile, like using Blink app or any web server. Web servers like IEEE 802.551, which will shows our home appliances on off switches like relays or access switches. Through this, we can operate. Uh, this is our module, which we prepared us. Through this module, we are connecting to our mobile. It will operate through our mobile. It is, and our remaining will be explained by our team member Yashwant.
Hello, sir. My name is Yashwant. I'm going to give a brief conclusion about our project. It is a IoT based project. Here we use Node MCU, which has inbuilt Wi-Fi module to control relays as globally. It is one of the easiest and most pocket-friendly home applications, home automation control system based on IoT. The project proposes an effective implementation of IoT used for monitoring and controlling the home applications via World Wide Web. Home automation system uses the portable devices as user interface. They can communicate with home automation network through an internet gateway by means of low communication protocols like Zigbee and Wi-Fi. The user here will move directly with the system through a web-based interface over the web, whereas home applications like lights, fans, ACs, etc. are remotely controlled through easy website like a Blink application in mobile. The server will be interfaced with relay hardware circuits that controls the applications running at home. So basically, we will send a signal from a phone with a Blink app, which will then received by the Wi-Fi module E8266, and then it will send a on or off signals to the relay, in which then will turn on or light or turn off the light, vice versa. Thank you, sir.
Yeah, thank you. Any queries, questions? Okay, if there are no questions, we'll move on to the next team. Yeah, thank you, team 19.
Thank you, sir.
Thank you, sir.
Yeah, thank you. Team 20.
Yes, sir.
Industrial IoT and DCS integrated energy meter monitoring and controlling system. Anandan, Manobala, Munishwaran.
So can we start?
Yeah, you can start. Yeah.
Yes, sir. Wait, so let me share the screen.
Yeah.
So my audio is visible?
Yeah, visible.
Yeah. Good afternoon, sir. Good afternoon to one and all present over here. We are the students from Arubadividi Institute of Technology, Chennai. Myself, MK Monobola. I'm going to explain about the introduction of our project. In today's modern era, digitalization is seen as an opportunity to achieve higher level of productivity and mass customization of products. It is the main backbone behind the Industry 4.0 technologies and allow easy interconnections of multifunctional and multidisciplinary devices. It play an important role in industries through which can be accessed control over the agility. the problem statement of our project. In all over the world, there is a lack of utilization of energy in an efficient way, and the population is also increasing day by day. Due to this production of electricity is also increasing there by the pollution or rate also increasing. So to reduce it is we can came up with the solution called IIoT and DCS integrated energy meter monitoring and controlling system. The objective of the project is getting more attention for efficiency energy management system such as monitoring, utilization and distribution. So the proposed system utilize the Internet of Things for collecting the power consumption. The smart meter is linked with the to the IIoT, which is cloud interfaced and remotely accessed. Hereafter, the block diagram and the hardware setups will be explained by the teammate Anandan. Thank you.
Thank you, Manabala. And this is Anandan from AVIT, and I'm going to explain about the block diagram of our project. Am I audible? So this is the block diagram. Yeah, thank you, sir. And this is the block diagram of our project. So from the LoRa, as you can see here, from the LoRaWAN, the signal which is transferred to the relay by optocoupler, the relay which performs of switching operations of contactor, which deals with the high voltages. Further, the signal transmitted to the energy meter. From meter, the signal transferred to the load, which we are using. The energy meter, which collects information from the load, and information is passed to the LoRaWAN transceiver as a feedback signal. Therefore, the signal is transmitted to the IoT 2040. Further, it transfers to PCS7, which processes the data and provides the output. So let me discuss about the hardware and components of our project. So this is the hardware setup photograph. As you can see, that this is a control panel, which is a distributed control system of our project. Using this, the process which should be done, and this is the product. This is our project product, energy meter hardware system. Let me discuss about the components of the product. So as we can see the LoRaWAN, we have used the LoRaWAN here. It is a communication device. So it can be operated in low power and for high range wireless communication. The nodes in the LoRaWAN can request acknowledgements. Hence, the signal is transmitted to Arduino, which is used for smart meter programming. And next, we can see the optocoupler. The optocoupler, it is also called an optoisolator, is an electronic component that transfers the electric signals between two isolated circuits by using the light. And we have used the contactor. They allow low voltage current to switch a much larger power circuit. And we have used relay. It is a switching component which acknowledges the contactor, through which the contactor may on or off, and which transfers the information to the energy meter. The next, the energy meter, it is an electrical parameter measuring device such as voltages and current utilized by the load. How the load consumes, the energy meter should take the information from the load. And next, the smart meter interfacing. The smart meter is interfaced to the Arduino through TTL converter, which converts the RS485 signal to RS232 communication data. And we have Siemens IoT 2040. This IoT 2040 is used to collecting, processing, and transmission of data. Hence, the collected information from the energy meter is processed and sent to the control panel. So the process of the software will be explained by my teammate Virmesh. Thank you.
Thank you, Anandan. I think I am audible. Okay, now I am going to explain about how the process which are carrying on in our campus. We are majorly processing it by three ways. First one is IIT control panel. First one is IIT, then one is DCS or otherwise known as control system, and the combination of an IIoT and DCS is cloud. First of all, we need to see about IIoT. IIoT, for that IIoT, we just using a secured IP address. With the help of that address, we can able to access the light switches within the campus. We can able to place that IP address in Chrome or or a laptop in anywhere, the mobile anywhere in the campus only. And we can able to monitor and analyze the data that how we are consuming and how much power we are consuming in the campus. And this is only for 2 to 3 nodes. If you taken one block, it can be controlled by one node, and another block another node. But if you come to industries, it requires major amount of that means it requires large amount of processing the data. For that, we just came up with ECS or control distributed control systems, which can be accessed in large amount of data. It can be used for multifunction and multi-purposing the data, and and used for multitasking. With the help of this, we can control the more number of things. For example, light fan in campus and machine systems in industries. The control panel is as it is like previously shown. It is user friendly, but the amount of data and how much processing time is reduced and the amount of data processing increased with the help of ECS. And the combination of this IIoT and ECS is cloud. We need to access the data from anywhere in the world. For that, we just came up with the cloud technology. We are using Firebase real-time database, which are available in an app and in software. For that, we require just a user ID and password. Once we are completing this steps, we can access the system from anywhere in the world. We need to give a command like 0 and 1. This 0 means that is an on-off condition. This 1 means that is an on condition. While giving this command, we can able to control the system from anywhere in the world. And more, and for not only for that, for easily combining many data and monitoring the data, we are using this cloud technology. And as a result of this, we can able to monitor the voltage, current, how much power is consumed by that budget, or how much power is consumed by your campus lights, fans, etc. So I'm going to conclude here. This is the integrated ECS and IIoT system proposed here offers wide range of weather controlling techniques and is providing efficient energy monitoring, which is very important for our future. The energy meter being interfaced with ordinum control helps us to automate the controlling process. By interfacing with the IoT 2040, all the data are collected from the small meter and the cloud enabled thereby the data can be collected and accessed from any point in the world. Future, every day is simulated in every meter, in energy meter. Application developed for the source purpose of meter monitoring and controlling actions from remote area. Future is going to be future is going to be face a major problem in energy consumption. We need to reduce it and we need to use more efficient way. For that, we just came up with this project. And the rest of the things explained by my teammates.
Sir, am I audible?
Yes.
Now let me share my working video.
The output coupler is also called.
As you can see here, this is the hardware of our project, the smart energy meter. So as we can see here, the what are the components which we have discussed before while I'm explaining the hardware system of our project.
The auto isolator is an electronic component that transfers electrical signals between two isolated circuits by using light. These are used to prevent high voltages from affecting the system receiving the signal and to provide isolation between low and high power voltages.
So now let me see how the project is actually works. Now we just saw the hardware part, and now let me control it using the software.
I'm going to on the switch with the help of picture interface. I'm just giving a command main on. Within the second, you will see that the light is on. And after I just giving a main off. Light is off. Okay, rest of the things explained by my.
So as you can see here, when we switch on the switch from the virtual system which we have made using the software, we can able to control the systems present in the inside our campus. So that's all about our project. And the novelty of the project is controlling and monitoring the energy consumption using the industrial IoT and the distributed control system. So that's all about our project, sir. So thank you for providing this opportunity.
So yeah, thank you. Any questions? So okay, thank you. Batch number 20.
Thank you, sir.
Let's go with your team number 21. Energy efficient contactless hand wash machine by Bawa Halidu from Sanyani Technical University.
మేడం డిపార్ట్మెంట్లో ఉన్నామండి.
My name is Bawa Halidu from Sanyani Technical University, Bachelor of Technology, Faculty of Engineering, Electricals and Electronics Engineering Department. My supervisor name is Mr. Jonas Samuel Yabua. I'm here this afternoon to present to you my project by name Contactless Power Efficient Hand Washing Machine. Contactless Power Efficient Hand Washing Machine. Someone may ask, what is it about? Contactless power efficient hand washing machine. It is a hand washing machine whereby the user need not to touch anything before using the device. So to start with, I'll be talking about the content, which is the objectives, the objectives, introduction, literature review, block diagram, hardware setup, photograph, results and discussion, conclusion. Right. Objective. What is my main objective of coming out with this device? My idea is to enhance the level of hand hygiene, to increase the level of awareness of people as regard to the proper washing and drying of hands in accordance, to solve a considerable fraction of the problem associated with washing of hands so as to reduce the risk of disease transfer between individuals, to expose the fact that the proper washing and drying of hands after holding objects using the toilet and even transfer exchanging money between individuals will geometrically reduce the rate and or presence of all evil in the area. Introduction. Hand washing machine. One of the major problem or one of the major transfer of virus is through our hands. One, especially those who are living in the areas like markets, schools, hospitals, cinemas, stadium, just to mention but few. These people can do away without sharing objects or shaking hands. So due to that, disease transfer is always high when it comes to these places. So because of that, we are trying to prevent such a problem. So hand washing is not only in the medicinal sector, but it is globally, and it is even advised in some religions where hand washing, face and feet washing is the order of the day or is part of their mode of living. To come to agricultural industries, food poisoning can also be caused by improper hand hygiene. So in agriculture sector, their main focus is also in what? Hand washing. So actually we have hand washing machines a lot in the system. Some are Veronica buckets, others are also hand washing machine. But this kind of hand washing machine actually demand manual operation. There is a need of what? Contacts before you can operate it. You can't operate it without what? Contacting the machine. But I realized that going to wash your hands in this hand washing machine, for instance, the Veronica bucket, you may use your hand to open the tap. After washing, you cannot leave the water run and you have to go back and close the tap. So let's assume that if you were affected by virus, you come and introduce the virus to the tap in the first place. After washing, you cannot leave it run and you go back and close the tap, meaning you are picking the virus back. So that means that you do not even do anything. Not that one alone. Assuming affected person come and use the device and you, the non-affected person, come to also use that same device, you'll be affected by virus. So I realized that those hand washing devices is rather to help to spread the virus faster than to solve it. So that's why I came out with this hand washing machine to bridge the spread of the virus, in the sense that I designed a hand washing machine whereby you need not to touch anything in order to wash your hand. What you need to do is just to stretch your hand and sensor will detect your hand. After the sensor detecting your hand, information will be sent to the Arduino board. So as the information is sent to the Arduino board, the microcontroller will transfer that information to the relays, and the relays will operate the motors and the pumps automatically. So if you stretch your hand, some few seconds, soap will come. When the soap comes, you use it to rub your hands. After rubbing your hands, the water will follow, clean water will follow. After washing your hands with the clean water gently, immediately you finish washing your hand, the tissue too will come out and you go in for the tissue. So this is the block diagram of the project. And this block diagram is just to summarize how the project look like. In the first place, we have our power system or power supply. This power supply is connected to the microcontroller and the sensor too is connected to the microcontroller. Now the power supply is also connected to the motor, the water pump, and the soap pump. So when the information is sent to the microcontroller, that information will be channeled to the soap pump. After that, it will channel to the water pump. After that, it will channel to the tissue pump. So that is how the block diagrams is all about. So this is the hardware setup photograph of the whole thing. When I started with wood. So I cut the wood into a reasonable dimensions. After that, I fixed the woods together to form a box. So this box, I divide the box into 3 chambers. So the first chamber is also divided into 2 sections. One section is for tissue and the other section is for the electrical components. So now the middle chamber is where the sensor is mounted. Down the sensor, we have the washing sink. At the left-hand side, we have the soap inlet. At the right-hand side, we have the water inlet. So now, when you put your hand in it, the sensor will detect your hand, send the information to the Arduino board, and everything will operated automatically. So now we fill soap into the soap inlet to the soap container and fill water to water inlet to the water container. Now let's come to the down chamber. The down chamber, we have 2 containers there, or 2 basins there. Each container, there is a pump mounted on it. So this pump pumps the water to the top, as well as the soap. So now, but we realize that filling in the water, we don't have water gauge to indicate that the water level is this, the water level is that, or when the water is finishing, we don't have anything to detect that the water level is finishing. So because of that, I see that it's another killing. So I designed a water level indicator, and this one I use a floater. So the way I designed the water level indicator is I get a floater and I gave it 2 contacts. For the soap side, and this in the water side too, I mount another floater and gave it 2 contacts. So now when the water level is decreasing, gravitational force is pushing the floater down. So as soon as the water reaches to 10%, the gravitational force will push the floater and make a contact and buzzer will sound to indicate that water is about to finish. Now, so when we come to the soap, when we come to the soap, it's the same thing. When the soap is reducing, the gravitational force is pushing the floater down to 10%. The first contact to what? First key will close and make a contact to what? To close the loop, and the buzzer will sound. And if the water is also hot, if you are filling in water, the abstract force of the water is pushing the floater top. So as soon as the water level reaches 90%, the floater will make a contact with the second key, and that one will close, and the buzzer will sound. The same thing if you are filling in the soap. When the soap reaches to 90 degrees, you are filling in the soap, the abstract force of the soap is pushing the floater top. So as soon as the floater gets to, the soap level gets to 90%, the abstract force of the soap will push the floater top and make a contact, and the buzzer too will sound. Now we realize that when it is in between 10 to 90%, you will not hear any sound because at that time all the two keys are open. So that is how the down chamber is also designed. So that is about, now we are talking about the results and discussion. The development system shows in figure 1 can be implemented in areas where there is a huge crowd and chances of infection are quite. Therefore, it can be used in educational institutes, houses, hospitals, and offices, just to mention but few, to stop the spread of coronavirus. The PIF sensor sends the user hand and initiate the microcontroller. The Arduino Uno then sent the signal to the DC motor pumps. The liquid soap comes and then what? Followed by clean water. After the clean water, the soap will then what? Follow. And the interval, the time delay the interval is just 30, just 61 seconds. That's what, 60 milliseconds. And that is the time delay. So the buzzer system, as I explained, it works like the way I talk about. So the results and the discussion, you can see this is the picture of the whole thing. Continue. Video. Yeah. So I have a video to show. Thank you. Okay, I'm now in the conclusion. The implementation of hand wash sanitizing system for sanitizing is efficient and the cost price is minimized. It works like the normal contactless automatic machines. The hand washing system provides liquid soap, water, and tissue for the user to wash the hands. This system helps to protect the user from getting some communicable diseases such as flu, TB, coronavirus, just to mention but few. And the price too is very low because most of the items are self-designed and the little components I bought to make this design. But majority part of the work is self-designed. For example, like the floater, the alarming system is self-designed. So thank you very much. God bless you all. We wish to meet you next time.
Yeah, thank you very much. I'm having only one question. Okay. So whenever there is a shortage of water or so, you are giving a buzzer. Am
Yes,
I right?
sir.
Yeah.
Yes,
Okay.
sir.
Okay, but how do I identify whether there is a shortage of water or soap? Do you have any unique sounds or unique alarm?
Yes, the water shortage. When the water is reducing, when the water is in the range of 10, in the range between 10% to 90%, you will not hear any buzzer sound. But when the water is reducing, that means that the floater will be coming down. And as soon as the water reaches to 10%, the floater will make a contact to close a key. And when this key is closed, the buzzer will sound. And when you are filling in the water too, the floater will be coming up. The axial force will be pushing the floater top. So as soon as the water reaches to 90 degrees, 90%, you see that the floater will make a contact. That's why the floater is having two keys. So when it reaches to 90 degrees, the second key will also close and the buzzer will sound. So that is the way you can use to detect the absence of water or overflow of water. So this buzzer system is to prevent overflow and also to prevent a dry run.
Okay, okay. But how do I identify that whether there is no water or there is no soap? Okay.
Yes, the only way you can indicate that you can identify that there's no water, buzzer will be sounding. You will be hearing some buzzer sound, pee, 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 telling you that there's no water. So you have to come and top water. So if you're also topping the water, you will not hear any sound until the water reaches to 90%.
Okay.
So if you hear the buzzer, that means that the water is about to go overflow, then you stop.
Okay. Okay. Thank you. Thank you for the presentation.
Okay. Thank you, sir.
Thank you. Thank you. Okay, we'll go with the next team. If anyone is having any doubt, no doubts means. Any questions from the participants? Yeah, so no questions. Okay, thank you. Baba Halidu. Okay, we'll go with the next team from the same university. Solar-based power supply for a summer hut at a Sanjani Technical University by Alex and Christopher.
Good afternoon to you all. I'm the person of Naya Christopher, and my group member, Sapphire Alex, here with me. Our project is solar-based power supply for summer at Siena Technical University. Our supervisor is Dr. Rajalingam. So we'll start by sharing our content, which we are going to look at the objective of the project, the introduction, the block diagram, the hardware setup photography, the results and discussion, conclusion and future works. So the main objective of this project work is to So the main objective of this project work is to model and construct a standalone photovoltaic system Let me solve this problem and get back. The main objective of this
So please switch off the remaining mics.
Yes, it's done
It
now.
is echoing.
Yes. Let me.
Yes, sir.
Sorry for the inconvenience.
Hello, Alex and Christopher. Please unmute your mic and speak. It's not audible. Yeah.
Yes. Sorry for the inconvenience. Please,
Yeah,
can you
okay.
hear me now?
Yeah, no problem, no problem.
Can you hear me now? Okay. So the main objectives of this project is to model and construct a standalone photovoltaic system to power the summer hut in the Sunyani Technical University. So modeling, we needed to take the load assessment of the summer hut and the sizing of the solar panel, battery and charging units for the whole system. Then we also in the construction to optimal placement of the solar panel, the light bulb, and the charging unit. We have to consider all these factors into developing the system. Optimal placement of the entire housing of electrical components. So after we finish, where are we going to position all our electrical equipment and how secured are they going to be? So in most developing countries, including Ghana, power is not always sustainable. Power is always an issue. It is not very reliable in our country here. So, and we, as I said earlier on, the summer hut is the place where students come to sit down and then they have group studies. We have other academic related activities in the summer hut. But the issue is the summer hut doesn't have power supply or there is no electricity available in the summer hut. So there is that need for us to develop a system where we can power the summer hut off grid because of the unreliability of the grid system in Ghana. So we decided to design this solar power summer hut. We propose the solar hut power supply by solar power for the university. So I'll allow my colleague to continue with the other presentations.
Thank you very much. With the block diagram, we have the whole system consists of 4 particular sections, which is the solar panel, the charge controller, load, and the battery bank. So we considered the types of materials or components that we are going to use, which we have stated in the block diagram. So with the solar panel, during the sizing, we realized that we can use a 100-watt panel to use for this particular work. Then we did a calculation to also go at get the size of the charge controller to charge the battery bank to. And our battery bank that we are using is 100 AH 12 volts. Well, we are dealing with a 12-volt system. Then when we come to the load, That is for brightening the summer hat, we need the illumination around 300 lux. So we decide to use a lux meter to get this particular illumination. So we had 5 different loads, lamps that we are using, which is the 5 different lamps, which is 30 watts lamp, 20 watts lamp 2, and the 5 watt lamp 2. Then we also have a charging unit also. So the charging unit is 24 volts, which consists of 14 ports for charging the mobile devices. So we want to design the system in a way that when you come to the summer hut to sit for studies, as you are there, you can use your phone to go through your PPT, to go through your Word document. In case your mobile phone device ran down, then you can charge it, or you can use it to charge your power banks to use in case you are over there or take it elsewhere. So these are our system design specifications. So on the first one, we have the first lamp that we use, which is a 20-watt lamp. And this 20-watt lamp, we are using 2 of them, which is being run for 12 hours every night. Then we have the second lamp, which is also 30 watts, the same 12 hours every night. And the third lamp, which is the 5 watt, 2 of them for brightening the place in the night. Then we have a charging unit for charging mobile phone. So a USB port is there. All you have to do is to come to the summer hut with your USB cord or cable. So once you are there and you need to charge your phone, you connect to the USB port to charge your phone. So with the sizing, we came out with this particular formulas that the total load demand over the hours of sunshine. So we had 184 watts for the sizing of the panel, which will give us a total of 200 watt panel. Then we also look at the number of panels that we can use. That is 100-watt panel, 2 of them in series. Then when we come to the battery, we did the battery. We have to use the total energy demand or divided by the battery efficiency, which is the lead acid battery that we are using, which is 0.85. Then we also multiply it by the depth of discharge. We want to drain the battery to 60%. So meaning that we have 40% remaining so that our battery does not go totally off. Then the system is a 12 volt system that we are designing. So all our loads are 12 volts load. So this gives us 12 volt system. And the day of autonomy is the number of days that we want to use this particular summer hut without charging. So our system is designed to run for only 1 day without charging. So in total, we had a total of 200 battery. That means that we are going to select a battery of 200 So we decide to get 2 batteries in series, 2 batteries in parallel rather, to get our 200 to power the system. Then with the charge controller too, we took the panel wattage and divided over the system voltage, which gave us 16.7 amps. With this, that means that we have to select a charge controller that is a little higher than this particular rated. So we took 20 amps charge controller. So this is the hardware setup for photography. We mounted the solar panel on top of the summer hut, which is 45 degrees to the north, to the south of our location, to get the maximum output of the photons, so that when the day starts, the sun starts rising, we will get the maximum output of the sun. So this is how we did the installation on top of the roof. Then we design a box, a metal box to fasten this particular charge controller and the charging unit, and to also house the batteries. So this box contains all the necessary components that we use for the project. So the battery is fit inside very well. Then the charge controller phase for us to read the charging of this battery, the the current, and then the battery level to be indicated. We fix it inside to project it outside so that we can, when you go there, you can see the charge level of the battery. Then the USB port is also showing in front of the box, so that when you come there, you don't have to interfere with the system, like opening the whole box to have access to the charging port. All you just have to do is to come with your USB port, connect direct to the USB, the charging system, then you'll be able to charge your phone. Then we have the 30-watt lamp, one which is here, then the 5-watt lamp, which is also here. So after installation, we tested the system to see how it was working. So you see that we've tested the system and then the light is on. Then when you go to the next picture, we were charging a phone and a power bank, and you can see all the two devices are charging. Then when we open the box and you look inside, this is how we did the connection. We fastened the battery to the box very well so that even when the table gets shaken, when the table gets shaken, it doesn't affect the battery or there is no movement in it. Then we also fasten the charge controller and the charging unit to the container so that once you open it, it doesn't fall off. It remains there completely. Then with the lamp, we have a photo cell that we use to control the on-in and off-in of the lamp, which is in this small box. So the photo cell is to turn on the lamp at night and turn it off when day breaks. So this is how we are able to design our system. So at daytime, this is how the summer hut looks like, where students come to sit down, relax, have academic discussion, do their project works and other academic related activities. Some lecturers even come there to mark their scripts and other stuff. So at night, after the installation, this is how the place is. We were able to achieve our aim by uh, giving the summer hut a bright lighting system for studies.
Okay, so in conclusion, we were able to model and construct the solar power system for the summer hut successfully. We completed that by enabling it, and it works 24/7 without any problem. We tested this and then it's working well without any issues. This project created awareness and promotes the usage of solar energy at the university. So because of this, we try to go into solar system, which will reduce the cost on electricity in the campus. So because of this project, there are other projects where the university is now thinking of going into solar system. This project also helped to develop community to power the lightning load without using the grid power. As I've said, we are not relying on the grid to power the summer hut. We are powering it by solar system, which is a standalone supply. So in our future works, we are intending to add CCTV to the summer hut by monitoring and then for monitoring and security purposes. Now we are giving students the opportunity to study at the summer hut in the night. We are intending to have a CCTV there where we will monitor the activities of students in order to avoid theft and then other security related activities which might cause harm to the student. So we intend to add CCTV into the summer hut. Similarly, we facilitate we similar facilities and buildings shall also be upgraded to solar power system. We are intending of adding more gadgets and other systems which we will use for this same solar project. We have a video demo which we would like to play. It's no share. So basically, we are describing the charge controller, and then inside the method. So we fasten them so that it's easy for it to flip around and for security purposes as well. So this is our LDR, our photo cell. Then is the switch that we can always power the system. So when it's in the evening, power on. So we are demonstrating the charging. Now when you plug, you just have to plug your USB, and then we can see that the phone is charging. So we actually tested a phone charging it fully from low battery, then we charged it to its maximum capacity to demonstrate and to be sure of the system actually working. So we are trying to illustrate by just shadow photocell to see if we have our light. Yes, and our light. All right, so that was our demo for the our project. Thank you very much for the opportunity, and we'll be listening for any questions.
Yeah, thank you. Okay, any questions from the participants? Yeah, thank you. Alex and Christopher.
Yes.
Yeah, we will go with the next team. Conversion of a conventional bicycle to an electric bicycle. Elijah Akesh Inoj.
Yeah. Good afternoon to you all. Conversion of conventional bicycle to electric bicycle. I'm Elijah Teria Draco with my friend Akese Enoch. The name of our supervisor, Dr. Roger Lengam Sativel Sani, Sunyani Technical University. The content of our project: objective, the introduction, literature review, block diagram, hardware setup, results and discussion, and conclusion. The main objective of this project is to develop battery-powered electric bicycle that carries a load of 100 kilograms by assembling various components to convert the conventional bicycle to electric bicycle, and also to test its operation in both manual and automatic mode. Introduction. Students on campus commonly use normal conventional bicycles. An electric bicycle is a bicycle with an integrated electric motor which can be used to assist propulsion. The bicycle uses DC motor which is powered by rechargeable batteries. Now, the main aim why we did this was that students on campus normally use conventional bicycle, and also the distances from lecture halls to the department is quite long. The hilly and sloping nature of the university makes it difficult for students and lecturers to go for lectures. So considering this as young engineers coming up, we made our mind to design a vehicle or a bicycle that will help with the easy mobility of we students and the staff. So before we did our project, we reviewed a lot of papers, and we had one, Vivek L. He proposed a bicycle with self-recharging mechanism. According to the method he used, 150 watts per magnet DC motor, which gives a 1,000 revolution per minute at 12 volts and 15 amps rating was linked, and he achieved what he wanted. And also another review we did about Shilok Desai. He represented foldable electric bicycle. So with his method too, it was possible. So we saw that we can do it. So now this is the block diagram of the project. We have the charger, the battery, the throttle, the motor controller circuitry, electric motor, the chain and sprocket, and the bicycle wheel rotation. Before, the power transmission system consists of the motor, the chain sprocket, the flywheel housing, and the rail wheel. However, before we could select these components, we performed some basic calculation relating energy transfer through the system. Primarily, we focused on the current requirement of the system, both the acceleration on flat ground and the hill climbing ability of the system. Before we could also size the batteries, we needed to estimate the motor and also know its ratings. So we did all this before we sized them. We did it through basic simulations. Now the working of it. The battery, 4 lead acid rechargeable batteries with 4H with 12 volts, 6.5 amp are used, which are connected in parallel position. The motor controller circuitry, it is used to control all the working of the cycle. It does this by coordinating in a predetermined manner the performance of the electric bicycle. So as we can see, the battery takes in the DC voltage and gives power to the motor circuitry, which is responsible for controlling the electric motor. So as it gives power to the electric motor, the motor also sends power, or it converts electrical energy to mechanical energy by sending power to the chain and sprocket, which is responsible for changing one form of energy to another. So that one too helps and aid in the bicycle wheel rotation. So this is the hardware setup photograph for the bicycle we built. So as you can see, we are having the motor being fixed to the chain and sprocket. We are also having the throttle there and the motor, as we can see, and the charge controller. The design parameters. We use a weight of 100 kg, a rate of 1.0 meters, height 1.50 meters, rolling resistance to be 0.02, and the air density we considered 1.25 kilometer per meter square. The drag coefficient we consider 0.30, the gravitational force 9.80, and the speed in kilometers 20.0, the frontal area to be 1.0, and the velocity to be 5.5. After we were done with all the calculation and the tractive forces, we had a tractive force to be 28.2 Newton meter per second, and the total power for traveling 20 kilometers, considering the short distances on campus, we had 157.114 watts. So this is the motor specification. The specification for the motor is the rated output power to be 250 watts, the rated voltage 24 volts, rated speed to be 3,000 revolution per minute, the no load speed to be 3,850 revolution per minute, and a full load current not less than or equal to 40 amps. No load current to be not less than or equal to 2.2 amp, and the rated torque to be 0.80. The efficiency was greater than or equal to 78%. The motor had the serial number, as we can see, the MY1016Z2. So this is how it operates. I want to show the video. So this is the demonstration of the electric side of the bicycle. We are moving without paddling it. In case when the battery is down, you can paddle it. So if you are traveling and the battery is down, you can paddle it. So this bicycle is a dual functioning bicycle which we designed for Sunyani Technical University. This is the demonstration of bicycle, and we also have outside campus demonstration. So this one is outside campus demonstration. We wanted to be sure whether it can travel outside campus, and that one too, that's the demonstration you can see. So that's the electric bicycle. So as I first explained the hardware setup, as we can all see. So the main difference between this bicycle and the normal conventional bicycle is that for the normal conventional bicycle, we have no motor and controller. But with this one, we've added the motor and the controller and the throttle to it, so that physically challenged students and real students with the hill climbing and other styles will be able to paddle the bicycle or walk with the bicycle without any stress, and it will make movement also simple for us. So in conclusion, the electric bicycle will make it easier for students and staff in short distance transportation on campus. For instance, for you traveling from the science park to the roto laboratory is sometimes a disturbance to most of the students because the road there is very hilly. So we coming and going back to that place alone makes it difficult for us. So this one has helped us a lot. And also physically challenged students can also cope using the electric bike as a means of transport. This is the future works that we hope to do. Now we are hoping that the bicycle can be modified into a tricycle by increasing the size of the motor and the battery, which we'll be doing next year. And also it can gradually be modified into the future. It can gradually be modified in the future to a four-wheeler e-vehicle, which is the main motive of the school. Now the school is having the motive of designing a four-wheeler vehicle. So with this at a start, I know that definitely by next year we will start with the four-wheeler bicycle too, the four-wheeler e-vehicle too. Thank you very much.
So any questions? The participants. So, okay, thank you, Elijah and Enoch.
Thank you.
Thank you very much for your presentation and participation in this competition. So we're having one more team.
Yes, sir.
Praveen
is here.
Yeah, Kamaraj College of Engineering and Technology.
Yes, sir. Can I share my videos?
Yeah.
PPT, sir.
Yeah.
Thank you, sir.
Yeah.
Is my slides are visible, sir?
Yeah, it's visible.
Okay, sir. First of all, I am very thankful to Vardhaman College of Engineering for giving me this golden opportunity to present my project in this forum. So first I introduce myself. I am M. Praveen and my guide name is Dr. D. Prince Winston. He is Dean Research of Kamaraj College of Engineering and Technology. And my research work is on parallel power extraction technique for maximizing the output of solar PV array. Then these are the content to present in this presentation. So first one is objective, introduction, literature review, block diagram, and hardware and the simulation results are there. I will discuss in the result and discussion forum, then followed by conclusion. So this is the overall objective abstract for my research work. In my work, I'll take that solar photovoltaics is the major one because why I am choosing the solar photovoltaics is to reduce the greenhouse effects, to reduce the zero carbon emissions in the pollution. To reduce the pollution, we will move towards the solar photovoltaics array for the electrical power generation. So in the upcoming modern world, solar photovoltaics really plays a vital role or crucial role in the power generation. So while move with the solar photovoltaics, the major concern is partial shading effect. So partial shading is the one of the major challenge while implementing the solar photovoltaic power plant. Nowadays, there are so many softwares are available to reduce the partial shading effect, like heligoscope or PV-Syst, to reduce the partial shading effect in the solar photovoltaic array caused due to some buildings or any other things. But still now there is a big challenge in the solar photovoltaic array. So under partial shading conditions, PV array is subjected to this more amount of power loss and mismatch loss. In between the array, there should be a mismatch loss in between the each rows in the strings are connected in parallel in the PV array. So it will lead to huge amount of losses. Even one panel is shaded in the PV array, it will affect the whole array of the system. So in this work, so my proposed work is to extract the mismatch power during the partial shading conditions and fit to the grid, electrical grid in the null irradiation time. Null irradiation time means in the night time. So in the night time, we can't generate the power. So with this power, we can extract the mismatch power under partial shading conditions. The partial shading condition, it may be due to some external buildings or trees or any other things. This is the one kind of partial shading. The another kind of partial shading is the dynamic partial shading conditions. The dynamic partial shading condition means that moving of clouds. So even the moving of clouds will create a partial shading scenario in the PV array by mismatching the mismatching of irradiation levels. There should not be an uniform irradiation level. There should be a mismatch of irradiation level in the PV array. It will lead to subjected to the more amount of mismatch loss and power loss, etc.
So these are the overall view of my abstract and as well as my research work. The main objective of my research work is to extract the mismatch power under partial shading condition. There should be a difference between the power loss and the mismatching power loss. Mismatching power loss, we can't reduce the power loss under partial shading condition, but we can reduce the mismatch loss under partial shading condition. There are so many literatures are there to reduce the mismatch effects in the PV array. The mismatch effect means that there should be an power deviation from the one row to the another row. Generally, we will the PV array is considered as an PV array matrix circuit. Yeah, it's like a matrix. They will set that panel 1, panel 1, 2. The location of the panel is says that in a matrix form. That should be a row column. So there should be an mismatching in between the rows. So we can extract in our proposed work, I would extract the mismatch power under the partial shading condition, and the mismatched power will be effectively stored in some battery banks, and then during the night time or without an early radiation time, that battery bank will feed to the grid. So these are my overall view of my research work. My motivation is main motivation is wastage of power under partial shading condition. Under partial shading condition, there should be much amount of power could be wasted. So there should be a lack of investors to invest on solar photovoltaic power plant due to some these kind of problems. So this will subjected to reduce some efficiency and performance ratio of the PV array. So performance ratio means that it should have some yield of PV. It is a ratio between the yield of PV array to its some reference point. So reference point means that under partial shading condition, it will how maximum it will the power will occur. So these are some literature reviews. The literature reviews. In my literature review, some papers are already published to reduce some mismatch effects in between the PV array. There should not be in none of the literature survey. They will extract the power under the PV. They will not extract the mismatch power under partial shading conditions. They will just minimize the mismatch loss as well as the power loss. So in the first paper, maximum power from the PV array using a fixed reconfiguration technique under different shading conditions. This will be published in IEEE transactions. Then in this paper, they discussed that they will propose that some static reconfiguration technique. Static reconfiguration technique means that physical relocation of the PV modules from one place to another without altering its electrical connection. So this is called the static reconfiguration method. By this static reconfiguration method, they will disperse the shading effect. So they will disperse the shading effect in the entire PV array. So thereby they can maximize the PV power, output of the PV power, but it should be some complexity in nature. So that's it can have the more amount of line losses. Resistance. So these are the line resistance are maximum. So these are some drawbacks in this literature survey. So it should be complexity also. Then second paper is a simple sensorless and fixed reconfiguration technique for maximizing the power enhancement in the PV systems. This paper is also got published in Elsevier publication. This is also a static reconfiguration method to reconfigure the PV array under non-isolation condition. Non-isolation condition means that ununiform irradiation patterns. Then the third work is enhanced power generation from the PV array under partial shading condition by Sudoku reconfiguration technique. Sudoku reconfiguration technique means that the Sudoku game puzzle system is directly applicable in the PV matrix array to reconfigure the system, and also it will enhance the power under partial shading condition. So the fourth one is optimal Sudoku reconfiguration technique. This is also an optimal Sudoku. This is the updated version of Sudoku method. Then this is also a fixed reconfiguration technique. Then the second one is optimal photovoltaic reconfiguration to reduce the partial shading. It is a dynamic reconfiguration technique. They will not physically relocate the panel, but they will altering its electrical reconfiguration with the help of some switching matrix circuits. So with the help of some switching matrix circuit, they will reconfigure the PV array, and then they will maximize the power under partial shading condition. These are also some limitations, such as it will have some additional cost of relays, SSRs, and so many things are there. So this is some dynamic reconfiguration technique to maximize the PV array. Then the final one is a novel BAT algorithm strategy for maximum power point tracker in the photovoltaic energy systems under dynamic partial shading condition. In this paper, they proposed that they will design a converter to track the maximum power in the PV curve. So during according to the characteristics of the PV array, they will give the they will maximum peak power under GMPP and LMPP. GMPP is global maximum power point and LMPP is the local maximum power point. So in order to overcome that, we should exactly extract the GMPP, global maximum power point. But they will in sometimes some converter fails to extract the power. But in this algorithm, now the BAT algorithm strategy is used to extract the maximum power under the partial sharing conditions. So these are some literature surveys. In this literature survey, I have identified some research gap with the literature review. So that research gaps are from all the literature survey, they will mainly focus on the reduction of power loss and the reduction of mismatch loss, but they will not nullify that mismatch loss. In none of the literature review paper, they will not zero mismatch loss. So there should be some mismatch loss, but there should be have some minimum mismatch loss. So there is no usage of minimum mismatch loss. There can be reduced the mismatch loss under partial shading condition. So with this conclusion, I will move towards my work. My work is mainly focused on the extraction of mismatch power and efficient usage of the mismatch power under the same partial conditions. In all the scenarios, I would extract that mismatched power in between the rows with the help of some electronic converters and fed back to the grid during the night time. So even night time also we can and fed to the grid. So this will greatly increases the stability of the system. The overall power system stability should be increased. So in order to overcome that, we can design some circuits and also we implemented in the real-time tested PV array. So the main problem in the conventional power system, as a power system engineer, the main problem I faced is power intermittent usage of solar photovoltaic array is power intermittent. Power intermittent means that the to the load we can't evenly supply to the load, because during the night time or early radiation time we can't meet the demand of the load. So with this help of technique, we can reduce those problems in the PV array. So these are the general conventional method taken for our reference to validate our work with that comparison. So this is a general TCT reconfiguration technique. The second one is simple TCT reconfiguration. These techniques are already I discussed in the literature review. Then third one is the shifting based reconfiguration technique. Then fourth one is the Sudoku reconfiguration technique. These all are the PV array output is fed to the grid side DC to DC converter. That is also called as MPPT converter and inverted and then it is fed to the AC grid. Then in my proposed work, I proposes that under some partial shading conditions, I would extract the mismatch power in which row is partially shaded. So in which the partially shading means that that row minimizes the current. The remaining healthy rows, it will affect the adjacent healthy rows also. For example, if the healthy rows the current output from the healthy row is 1 ampere. If the partial shading condition row is around 0.5 ampere, means that the entire output of the PV array should be 0.5 ampere. That 0.5 ampere should be dominant in between the among the each rows, then it will come out. So in my objective is that 0.5 ampere, the remaining resultant 0.5 ampere in the both two healthy rows is wasted. Actually, that should not be come outside of the PV array. That should not be dominant. So in that healthy PV array, I will connect parallelly the converter from the healthy rows. I will adjust the duty cycle of the converter and I will extract the mismatch current in that healthy rows. So evenly I will extract the 0.5 ampere from the healthy rows. Then the resultant output of the current is 0.5 ampere. The partial shading row that will also produces 0.5 ampere. So evenly all the currents are evenly separated. Then it will give to the grid the mismatched current as per the voltage is extracted with the help of some external converters and stored in the battery bank. So this is our proposed circuit diagram for a simple case. I think I will taken that the second row should be partially shaded. So A21, A22 and A23 is partially shaded. So the current developed from the partially shaded row is 2.8 ampere. In that remaining row, 3.1 ampere. The first row and the third row is 3.1 ampere. Nearly the first row is 3.1 ampere. They will first row they will develop a 3.1 ampere. In the last row itself also it will develop a 2.9 ampere. But the entire output of the PV array should be 2.8 ampere. So the 0.3 ampere, the mismatched current of 0.3 ampere is wasted in first row, as well as the 0.1 ampere is wasted in third row itself. So there should be some mismatches. So I will extract that 0.3 ampere from first row and 0.1 ampere from the third row. Oh, with the help of some external power electronic converter, by adjusting its duty cycle, it will stored in some batteries. The remaining 2.8 ampere will be fed to the grid. So this is my proposed circuit. This circuit is simple for just for one case. That case is I will show in the later slide. So this is my proposed flowchart. So in this proposed flowchart, they will measure VMF, IMF is the I will segregate this operation in the two sides. One side is the front side. Front side means that normal grid DC to DC converter, inverter, and the AC grid. And backside operation. Backside operation means that the mismatched power extraction side. So that mismatched power extraction side is considered as a backside, as well as in each backside is connected with the battery bank. So then VMF is the front side voltage and maximum front side voltage, and IMF is the maximum front side current, and VMB is the maximum voltage developed in the back side and the maximum current in the back side. So these are the measurements. Then I will check whether it is in whether the array is in partial shading condition. I will check with the help of current sensors or voltage sensor. If the this will also have some drawbacks. So if we use current sensor, we will properly disconnect the load according for the certain slots of time. So we will series continuously disconnect the load. So to detect if the partial shading scenario is in PV array. So in order to in my work, there should not be an isolation of load is needed, because I am finding the partial shading condition with the help of row voltages. So with the help of difference in the row voltages, we can measure whether we can predict that if the partial shading scenario is in the PV array or not. So that's why I predicted the partial shading. So then I will, if the partial shading is detected, I will short circuit each row with the help of some SSR solid state relays connected in series with the current sensor. So I will measure all those row currents, and then I will find out the mismatch current, calculate the mismatch current with some calculations. I will show that mathematical relation in the upcoming slides. Then I will find that mismatch current as well as mismatch power. Then I will, with this help of things, I will give signal to the Arduino relay in to which converter should be operated. Because if we find that mismatch power, then we will categorize the mismatch current. Under this condition, the maximum mismatch in which row have the minimum row current, the remaining two rows converter will be operated, and the mismatch current should be extracted from the from those rows, and do some normal MPPT operation in the front side and the back side. In front side and the back side is charge the battery with the mismatch power. Then we can calculate the total power from the PV array. The total power is almost with the null of mismatch power. So this is my proposed flow chart. Then these are the design specification of my PV module. So in this PV module, for this I have tested in the small scale level. So for just a 3x3, I will simply tested in 3x3 solar PV array. The entire capacity of the solar PV array is 90 watts. The maximum power of each module is 10 watts. The open circuit voltage of each module is 12.6 volt, and short circuit current is 1.6 ampere. The maximum voltage should be 8.82 volt. The maximum current is 1.13 ampere. And I will use some ammeters, multimeters, and rheostats are for my calibration. So for my measurements, I will use that ammeter and multimeter. In this testing purpose, I will use that rheostat because the rheostat is connected across each row to vary the rheostat resistance level. I will extract the mismatch power, and parallelly I will connect the battery bank to store the mismatch power. For the testing purpose, I will use a rheostat to extract the mismatching current in the PV array. Then wires are as per record. And pyranometer is mainly used to measure the irradiance level of light intensity level of the sun. And these are the some mathematical relations of my proposed work. In this proposed work, I proposes that the main objective is we can find to estimate the row current of the PV array. So if we can predict the row current, if we estimate the row current, then will be we can do all those things. So for this row current summation of Kij into Im. So Kij is the is a constant that will related to the irradiation level G by G naught. G is the actual irradiation level on the PV array. G naught is the standard STC condition of the PV array, of the PV module. So G naught should be equal to 1000 watts per meter square. According to that, I will find out the minimum row current according to the all the row currents. Then IQ1, IQ2, IQ minus 1 is the mismatch current. How we can predict the mismatch current? Then maximum minus minimum mismatch current in the each row. So that gives the, so I will maximum I will ascending orderly. I will arrange that all the maximum row currents. Then I will subtract that minimum row current from the maximum current. I will predict that mismatch current. With the help of mismatch current, I will operate the. I will set that converter pulse to extract the mismatch current. So these are the resistance value, the load, the backside resistance value is the important thing. I can vary the resistance value with the help of uh, pulses, converter pulses. So the resistance value we can decide with the voltage across the each row divided by the mismatch current. That's a simple formula. Then we can predict the voltage level of the each row in backside. Then I will power in the mismatch power in each row that can be predicted. So up to m minus 1 means that up to the mth row. So this work is applicable to n level of PV array. So this is the general PV array formulas. This is the general voltage formula for the DC to DC converter. That means front side, normal MPPT side, we can predict the voltage and current, then power. PMF is the maximum voltage in the front side, and IMF is the maximum current developed in the front side. So then the total power means that the power developed in the output of the PV array with the summation of mismatch power that will be extracted in the converter side, that should all included in the total power of the PV array. So these are the simple mismatch loss equations. So these performance parameters are included to validate our work with the conventional works. How our work is improvised with the conventional works. So these are the parameters are taken to validate our research work. So first one is the mismatch loss. This one is the mismatch loss is the difference between the ability to generate power under partial shading condition to the maximum power under the partial shading conditions. So then percentage power loss and the fill factor. Fill factor is the common phenomena to validate the performance of the PV array. If the fill factor is high in each PV module, then it will the performance ratio of the whole PV array or the whole PV module, it should be good. So these are the, then I come to the result and discussion part. So these are the shading patterns. So I think I will taken nearly 8 shading patterns to validate our result. With the 8 shading patterns, all the conventional, I mean real-time scenarios, all the real-time scenarios are included in this 8 shading pattern. So I will take these 8 shading patterns. The first row is the uneven row, uneven column, and short wide, short narrow, long wide, long narrow, and diagonal shading pattern and random shading patterns. These 8 shading patterns are taken for validating our results. So this is a single diode modeling. So this our proposed work is validated in both the things. So in experimentation also 3x3 validation is there, and in simulation platform that should be in MATLAB Simulink also I will simulate and I will validate the results. So I will compare those simulation results and the experimentation results to validate my work. So this is a general equivalent circuit of the solar PV module. So initially first one is then current source is connected in parallel with the anti-parallel with the diode. So these are the two parasitic resistance. Like final equation is the general PV current equation that is come from the normal Kirchhoff's current law. So the second one is the diode current equation, and the final is the shunt current equation. The first one is the high pH, is the photon current. So this is my simple simulation results. So in this result is taken for uneven row case. That should be a first case. So for TCT, I will compare my proposed work with the conventional 4 techniques. The TCT is the common conventional technique, total cross state technique. Then second, I will mention the 2 is as an static reconfiguration technique. The 3 is then the static reconfiguration with the technique with the shifting algorithm. The fourth one is the Sudoku algorithm. Then final one is my proposed work. So these are the IR1, IR2, IR3 will be the row current of the each in PV array. The first row current 2, row current 3, and IQ1, Q2, Q3 is the mismatch current in with mismatching current that should be extracted in the PV array. Then IA, PA is the array current, array voltage, and array power. Then final PT is the total power. So in TCT, the current should be 1.5 ampere, 3.3 ampere, 3.3 ampere. The first row current should be minimum. So the first row current will be dominantly dominantly comes from the output of the PV array. So the array output current will be same as 1.5 ampere. The voltage is 29.2 volt. The power output of the PV array under TCT connection is 41.7 watts. Then the total power is also 43 watts. Nearly 41.7 watts is only. So in 2, 3, 4 is some reconfiguration techniques to evenly distribute the shading effects and maximizing the power. Under this condition, the total power generated is nearly 67 watts, 50 watts, and 67 watts. That should be output of the PV array. In my proposed work, I will find out the mismatching current, and I will extract the mismatching current. So I will find out that the row 2 and row 3 are the healthy rows. From these healthy rows, I will calculate the mismatching current. The mismatching current should be 1.8 ampere. So I will extract the 1.8 ampere from the row 2 and row 3. Then with the help of so the total power should be 72.3 watts. The general array output power is 39 watts, which is nearly equal to TCT reconfiguration. But the total power, because we can extract the mismatch power, then it will comes around nearly 72 watts. So this is my graph, which shows when compared with all the conventional techniques, our proposed work have the maximum output power in the PV array. So this is our performance validation. So I will calculate some mismatch loss, power loss, and fill factor for this under this partial shading condition. So in under all the shading conditions, I will reduce the mismatch loss to 0. So this is the main objective of my proposed work. So I will nullify the mismatch loss. So this is the one of the main advantage. This is the only one advantage of my proposed work. So in conventional, all the research papers, they have mismatch loss of nearly 31.7 watts, 25 watts. In some reconfiguration technique, there will also some mismatch loss of 7.9 watts. But in our proposed work, I will nullify the mismatch loss to 0. Then I will reduce the percentage power loss to 17 watts, 17.7 percentage. Then I will increase my fill factor to 0.61. So when compared with all the techniques, I will in my technique is have the greater impact in this condition. So this is the second case for my second validating case. So in the second case, I will take an uneven column shading pattern. In this uneven column shading pattern, the PV array, the first column of the PV array, or in any one of the column of the PV array should be partially shaded according to this climatic nature. So in this in the conventional technique TCT reconfiguration and some other techniques also have the same output power of 77.6 watts. But in my proposed technique, the total power output will be 79 watts, because I will extract the mismatch power from first row as well as the third row, the mismatching current of 0.3 ampere and 0.1 volt, 0.1 ampere. Hence, the total power output of the PV array should be increased to 79 watts. So this is my claim. Because in all the conventional research works, for this particularly for this uneven column condition, there should be an that should we can't minimize the power under the column condition because it is already evenly shared. So in this proposed work, I will enhance the power to 79.6 watts. So these are the performance validation. I will increase the fill factor of 0.64 to 0.68, and I will reduce the percentage power loss from 13.3 percentage to 8 percentage, and also I will nullify the mismatching loss. So this is for short wait case. This is third case I will taken. So in this case also, my proposed work have the maximum output power of 80.9 watts. I will extract the mismatching current of 0.8 ampere from the first row and the second row. So this is a short, actually I will mention that this is for the short capacity of the, I mean the capacity of small scaling PV array. So the scaling of the PV array should be very small. If we implement in the large scale PV array, we can drastically increase the output of the PV array and also enhances the overall system stability and also efficiency. Then the payback period also we can take in the short term of period. So these are the main, these are some objectives of my work. So these are the performance validation for the short wait case. Then this is a short narrow case. In this case also the maximum power is enhanced from 61.6 watts to 73.3 watts. So for short narrow case, we will improve the fill factor from 0.49 to 0.63, and we will reduce the percentage power loss from 33.3 to 15.6 percentage. So this is for long narrow case. In long narrow case also, the power should be enhanced from 50.9 watts to 62.8 watts. In this, nearly 10 watts of the PV power can be enhanced in this short scaling capacity. The overall capacity is also 90 watts. Out of these 90 watts, we will enhance it 10 watts. So this is the claim, it's the advantage of my proposed work. So in this also, I will reduce the mismatch loss to 0. Oh, then fill factor is improved from 0.47 to 0.54. So in the simulation case of last simulation case, this long wait case, in this case also TCT have the greater impact of 58.3 watts. But when compared with the TCT, our proposed work has the output power of 62.6 watts, nearly 4 watts will enhance the power under this partial shading condition. So for this random case, in all the research works, they will reduce the power of power from 50.5 watts to 35.8 watts. But in our proposed work, I will enhance the power enhances with the TCT from 50.5 watts to conventional TCT 50.5 watts to 55.4 watts. So this is the performance validation curves for my proposed work. So then I will come my for experimentation setup. So this is my experimentation setup. In this experimentation setup, I will use parameter for measuring the solar irradiance level, and I will use 9 solar PV modules connected in the TCT connection, and I will connect the rheostat to extract the mismatch power in the healthy rows, and I will have some ammeters and voltmeters are used for the measurement purpose. Then cardboard sheets are used to create the partial shading scenario in the PV array. So these are my hardware results. So in this hardware results, I will test only one shading case for that short wide shading case or uneven row shading case. So in uneven row, because when compared to the simulation results, uneven row shading case have the greater impact for my proposed work. So I will take an uneven row shading pattern in the experimentation. So in this experimentation, I will taken that insulation level of A11 module is 245 watts per meter square, A12 module is 490 watts per meter square, and A13 module is nearly 245 watts per meter square. I think that will be 825. That will be 245 watts per meter square. So in the remaining modules should be 980 watts per meter square. So in that second row will be get partially shaded. Sorry. So I will extract the power from the second row as well as the third row of current of 2.2 ampere, then the total power I will enhance it up to nearly 66.8 watts. So these are my work. Then these are the experimental validation graph for the mismatch loss, power loss, percentage power loss, and fill factor under all the shading for all the pattern. I will reduce the mismatch loss. In the experimentation, in simulation work, I will nullify the mismatch loss to 0. But in the experimentation, there should be an error in that converter side. So I will not equals to 0 due to some converters. So I will nearly minimize the mismatch loss of nearly 0.3 watts. So when compared with the other methods, this is very minimal, nearly equals to 0. So in this proposed work also, I will minimize the mismatch loss. Then this is the percentage power loss and the fill factor for my proposed work. So these are some highlights of my overall work. So in this presentation, discuss that the effective usage of mismatch power under partial shading condition. While comparing all the conventional reconfiguration schemes, the proposed technique improves the output of the PV array with the help of some extracting the mismatch current. This proposed work has the zero mismatch power in simulation case, but in experimentation there should be a lack of some mismatch losses there, which is nearly equivalent, which is nearly less than 0.5 watts in all the scenario. So mathematical relations are mathematical equations are developed to validate or to estimate our proposed work data. The detailed simulation for these techniques are well comparative to the conventional techniques with the help of MATLAB Simulink platform. In the existing PV array, the Sudoku gives the better performance compared to all the methods, but our proposed technique will the best performance in nearly all the shading cases compared to existing TCT, Sudoku, as well as the other conventional reconfiguration, both static and dynamic reconfiguration techniques. So this proposed mismatch current extraction method significantly increases the output of the PV array under partial shading conditions. So we can't avoid partial shading condition, but we can reduce the effect of partial shading condition in the PV array with the help of some these techniques. So in this proposed technique, even partial shading condition, the output power is increased from 22.7 watts to 66.8 watts, and the percentage power loss is decreased from in uneven partial shading condition 25.7 percentage to from 69.7 percentage. Then these are my overall conclusion. So in this overall conclusion, we will develop some converter strategy to extract the mismatch power, and also with the by extracting the mismatching power, we can improve the overall system stability, and we can improve the maximize the power under partial shading conditions, and we can improve the fill factor also, thereby we can reducing the power loss as well as the percentage power loss also. So this proposed technique will be very effective for the upcoming smart grid and microgrid in the overall power system strategy. So then these are my conclusion. Then these are my references which I referenced to carry over my research work. So these are the research papers. Then I will publish this year. I will publish this work in the publication of Solar Energy Journal, in the publication of Elsevier. So parallel power extraction technique. This paper has the impact. This journal has the impact factor of 5.742, and now onwards it will this proposed work have the citation of 17. Google Scholar citation of 17. So these are my work. Then I'll thank Aldo for the Vardhaman College of Engineering and Dr. B. Praveen Kumar to giving me this opportunity to present my research work in this forum. And thank you for your patience. Thank you all. Then I will have my video, my experimentation video. I will share my experimental video. So this is my experiment video. Actually, this is the overall experimentation setup. So to increase the maximum power under partial shading conditions. So in this partial shading condition, we will create with the cardboard sheets partial shading scenario. We will extract the maximum power with the help of some rheostats, and we will parallelly connected with the batteries also. So in this, we will measure those current values with the help of some partial setting scenario, and we will extract the mismatch power with the help of rheostats. And that time we will experimentally validate our results. So the power, these are the mismatch power. So mismatch current, nearly 0.25 ampere of mismatching current will be extracted with the help of this rheostat and some powertronic converters. That powertronic converters are activated with the Arduino microcontrollers. So this is my overall experimentation video. So I think I will explain all those things. Then thank you all for this wonderful opportunity. Thank you all.
Yeah, thank you. See, any questions from the participants? Yeah. So, okay, thank you for your presentation, Praveen.
Thank you so much, sir. Thank you for this opportunity and your patience, sir. If there are any questions.
Yeah, I think there are no more questions.
Okay.
So, okay, thank you. So, okay.
I hope that I will clearly explain my.
Yes, yeah. That's why no questions. Okay.
Thank you so much, sir.
Yeah, thank you.
Thank you all. Thank you, Ananda.
So thank you all for your presentation, and we will be announcing the results by tomorrow morning or by within afternoon. Okay, by after evaluating the whole projects. Okay, so in the WhatsApp, same WhatsApp group, whatever you have joined. Okay, so thank you for the patience and your presentation. Okay, thank you. I will be closing this meeting.